Hi, today we're going to do problems 513 and 516 in Gujarati and Porter Basic Econometrics. The first thing we need to do for 513 is it refers to actually an earlier problem in chapter 3, so we need to pull table 3.7. I'm going to go ahead and open with eViews. Okay. Now, sometimes you'll have to relabel these series, and sometimes you will not. So here you can see that they're already labeled properly. That's good. And check again. Finish. No, we don't need it to link. And then usually a good thing to do is to just check the series and just make sure that you've imported it properly. It's pretty obvious we have here, but I'm just showing you as a reminder. So, 463.54. Yeah, okay. So the first part of the problem is to estimate the two regressions, which if I remember from problem 332 properly, let me just get there. Or 322, excuse me. Yeah, gold price against CPI. So very easily we can just do LS gold price. You can also do this in the quick bar estimate equation. I just find it a little bit faster to do it this way. C and CPI. Okay. And here's our regression output, and we'll go ahead and name that equation 1. That's fine. And then we can do LS NYSE C CPI, and then we get our next output, and we can go ahead and name that equation 2. Okay, so we have both of our outputs here. The next part of the problem says, test the hypothesis that the disturbances in the two regression models are normally distributed. Okay, so we're going to use the Jacques-Barrat test, which is a test on the skew and kurtosis parameters in the histogram of the residuals. So here we have Jacques-Barrat statistic of 5.43. This is a p-value of 0.06, which means that there's a 0.06, given our hypothesis of normally distributed residuals. There's a 0.06% chance that we would observe a more extreme result here. So at a 5% significance level, we fail to reject the null hypothesis of normally distributed residuals. And this is important because we rely on the assumption of normally distributed residuals to carry out inference in many ways. Okay, so what about for the other equation? Residual diagnostics, histogram. And here we actually have a lower Jacques-Barrat statistic and lower probability p-value. So we can also fail to reject the null hypothesis for this equation. The next part of the problem asks to carry out a hypothesis test that beta 2 equals 1 in the gold price regression. So we can do that fairly easily if we look at coefficient diagnostics, and then we look at a Wald test, which is a coefficient restriction test, and then we simply set C2 equal to 1. Okay. So we get a test statistic here, a t-value of 0.09, which is very low. Doesn't exceed our critical value, I think, which is about 2 or something for a 95% confidence interval. So we fail to reject the null hypothesis that this statistic that we estimated, 1.03 for the slope, is equal to 1. So for our other equation, we do the same thing. C2 equals 1. And you can also do this algebraically. It's quite easy. You just use the standard error, and you have your estimated number, which is about 50 in this case, minus 1, which is your null hypothesis, divided by the standard error, and that'll give you this number, 12.4345. Very, very low p-value here. So we can happily reject the null hypothesis that the true statistic is equal to 1. And then, actually, many of you were a little bit confused about this notion of a hedge. And actually, this would be a hedge for inflation, because we would want an asset that appreciates with the CPI. So we would want a positive correlation between an asset that we were using as a hedge against the CPI, because we do not like inflation in this instance. And possibly the equity prices here, holding equities, would be a superior hedge than gold, just because of this very high and positive t statistic. Okay, so moving on to the next problem, which is 516, which is about the Big Mac index. We're using table, let's see, hang on. We're using table 5.9 in this case. So we do the same thing. Open with eViews. Go ahead and open it with Excel as well. Okay, as you can see, we don't necessarily get good names for these. So we can put them in ourselves by looking at this. So BMACLC, BMAC, implied PPP, so we can just call that IPPP. Actual exchange rate, so call this actual exchange rate. And under over, I don't know, under over. Probably better names here, but okay, and it looks good. So again, we probably don't have to check these, but I am, just to belabor the point, that it's useful to do, and it's something that you always want to make sure that you've done, because if you do it wrong from the beginning, then everything else obviously is a waste of time. So here we have IPP, and it's correct. Okay. So we can proceed with this work file. And the first part asks us what values of beta 1 and beta 2 would we expect if the theory of purchasing power parity holds. Well, we would expect the intercept to be 0 and beta 2 to be equal to 1. And the reason is that long-run exchange rates will tend to sort of gravitate around the purchasing power parity via arbitrage. And then you'd expect to sort of relationship that maybe wasn't exactly one-to-one, that wouldn't be statistically distinguishable from one-to-one. And so we're going to test that in this case using the crude Big Mac index, which could itself be a problem here. So what we can do is we can run OLS on the actual exchange rate versus the implied purchasing power parity. So let's do that here. So LS A EXR C. Always be sure to include your intercept. Sometimes it's easy to forget. And then IPPP. Okay. So most of the people got this result. 1.81 is our slope estimate for IPPP. And we're going to test the hypothesis that this is statistically significantly different from 1. And we do that in the exact same way as we did before. We look at coefficient diagnostics, Wald test. It's just to do it nice and automatically for us. And we get a very large t-value. So we can safely reject the null hypothesis that our slope estimate of 1.8 is not statistically different from 1. Okay, so what does this mean? Essentially, this means that given our use of this crude index, we've found some evidence against the idea that purchasing power parity holds in the long run. But this isn't a very good test of it, necessarily. So my personal feeling is that we can keep the Big Mac index around because it's funny and it's useful for educational purposes. And again, in this case, the data that we used, though, do not support the idea of purchasing power parity. Okay, hope that helped. See you guys soon.